Coralie. Let's start our Tech Talk.
Welcome to our Tech Talk, where we are taking you to a thrilling journey into the future of mobility. It's all about autonomous, software-defined vehicles that hit the market with a bang. I'm Coralie, Department Manager for Perception Software here in AVL Software and Functions.
And I am Klaus, Product Manager for ADAS and AD business in Software and Functions. Develop autonomous software-defined vehicles, bring them to market in time with a high degree of maturity and stay competitive. It is possible.
Car that can learn how to see and drive thanks to cutting-edge technology. Get ready, because this technology are going to make our roads safer, smarter and incredibly efficient.
You voted on LinkedIn. In addition to sensor AI synergy, you're interested by real-time data for security. Stay tuned and learn more. Everyone's talking about software-defined vehicles, right? It's all about software driving innovation in the automotive landscape today.
In the future, picture, automation, connectivity, electric vehicles. Customers are hungry for cutting-edge features. And software is what it's all about. SDV is a game changer, no doubt about it.
And it's not about the vehicle anymore, it's about features on demand. Architecture is key, especially EE architecture. Zonal domain computing is the future for EE components. So, Coralie, where do we begin?
A robust toolchain is crucial, one that aligns with automotive workflows and covers the full development spectrum from requirement till testing with full traceability. And AVL got this fantastic tool called Maestra. It's an integrated development and test environment that is a game changer. It ensures automotive compliant process for customers and enables development in a cost-effective and time-saving manner.
And the best is, it's not for AVL only. You as a customer can use it too. Efficiency and safety is crucial, so early virtual checks are a must. DevOps with continuous integration and continuous deployment brings automation to the forefront. In addition, standardized middleware, such as AUTOSAR, is essential for the future hardware and components. And of course, software quality is the key. Automotive SPICE sets the quality bar high. Compliance is the name of the game.
So stay tuned, because SDV is reshaping the future.
Coralie, you know, I have heard from customers that a lot of companies have parts of the new architecture down, but they lack real hands-on experience and years of development expertise.
Yes, it's a common issue, Klaus. There isn't even a legal framework for development. It can be quite challenging. But here's what's exciting. Our approach is all about pushing forward. We are not just waiting, we're moving.
Waiting just means losing precious time. We have actually worked on a bunch of different projects, both for customers and internally.
What kind of feature have we implemented?
We have introduced our Highway Pilot feature, for example, based on our technology vehicle platform. We even put it on a high-speed test track. Customer projects have been diverse. We worked on various ADAS functions and we delved into GSR. But it doesn't stop here. We have ventured into automated driving also, up to SAE level 4. Consider automated garbage truck or automated harbor loading vehicles.
That's quite impressive, Klaus. And let's not forget about our internal R&D project. They keep us on top of technology. Our ultimate goal is to provide our customer with high technical quality services. It's an exciting journey we are on. An example is Outbus project, which is an autonomous level 4 bus for transportation as a service and mobility as a service. Imagine you're losing market share and your sales figures are dropping. You definitely don't want to rush out vehicles that could damage your reputation. What if you have a good software architecture for your autonomous vehicle, but your safety measures are outdated?
Do you want to risk accidents or even human lives?
Absolutely not. And that's where we come in. Safety and security are essentials in AVL's processes. They are part of every step. We have an arsenal of tools for processes. Think about ARA, TARA, FMEA, functional and technical safety concepts. Safety is our top priority.
And you know, Coralie, we are not just talking the talk. We are actively involved in standardization and working groups, like ISO 26262 for functional safety or ISO 21448 for SOTIF. Plus, we are well versed in ISO 21434 for cybersecurity. We've got the finger on the pulse of the latest standards and precautions. Whether you need help developing level 4 driving characteristics with SOTIF aspects, or defining the SOTIF process with software and hardware in the loop tools, we've got you covered.
So you see, safety and security are not just buzzwords for us. They are at the core of what we do.
Coralie, we have this amazing advantage: years of experience in advanced and serial development. And we are super flexible when it comes to adaptations of changing regulations. We at AVL Software and Functions have the software and controls development in our DNA.
Yes, and that's the highlight, Klaus. We've got this incredible team working across all disciplines. It's like having the solution just one desk away. Our long expertise in serial development allows us to switch easily when conditions are changing, whether it is market demand or new regulations. Our customers get to tap into all that expertise. We help you to craft complex software solutions like no one else.
Exactly. So if you want to ride the wave of innovations with a team that's built for it, we've got you covered. With AVL, you not only work with a professional who increases your innovation speed, but you also get valuable knowledge for the development of autonomous vehicles and its architectures. We also learned a lot. Above all, we are concerned about the essential questions. How can we evaluate and process the data the vehicle sensors are recording? While you are watching this video, you are using at least one of your senses. In the vehicle, sensors like LiDARs, radars and cameras are the sensing organs.
And Klaus, have you ever wondered if and how we can trust the car's eyes? Consider the perception software in autonomous vehicles. It serves like the eyes and ears of the cars, but it goes beyond the human capabilities. It operates unaffected by fatigue or distraction and can process vast amounts of sensors data. In addition to online perception, which processes data real-time, we also use another system, offline perception.
So Coralie, what's so special about our offline perception?
To validate perception in the car in real-world traffic, an independent measurement device is needed. The reference system and pipeline should be vendor independent and highly accurate. That's why offline. Perception performance evaluation is the key for system under test and homologation purposes.
So the offline perception can reproduce dangerous traffic situations?
Yes, Klaus. It can help to simulate accidents in virtual environment to improve vehicle safety without taking any real risk. Offline perception can be processed in AVL in-house, but also customer can buy a license for their own sensor setup. Have you ever wondered which sensors power our perception and why they matter so much?
For sure, it is a crucial part of autonomous driving. Coralie, can we break it down?
Sure. First up, radar. It's a rock star for detecting objects at long distances, even in nasty weather conditions with rain and fog. It gives us accurate object speed, helping us to identify potential collision and maintain safe distances. Radar is not just reliable, it's also cost-effective, perfect for mass production for autonomous vehicles. And then the LiDAR, it's all about 3D point cloud data. It's like a detailed map of our environment that allows us to recognize the geometry and the distances of all objects around us, down to the tiny detail. Plus, the LiDAR can tell us if something is a pedestrian, a vehicle, or a static obstacles. Safety is all about to know who is who.
Cameras play a big role too. They capture color and video, giving us a rich visual information for tasks like lane detection or traffic sign recognition. And the best part, cameras are budget friendly.
We often use a mix of all these sensors. Radar and LiDAR for spotting objects afar, and the camera for the nitty-gritty details. Sensor fusion is the name of the game, creating a robust software perception for safe autonomous driving.
So the next time you see an autonomous vehicle cruising by, it is this sensor dream team making it all happen. To make sure that all of this sensor dream team is working together seamlessly, we have our facility, the Center of Mobility and Sensor Testing in Roding. There we manufactured our equipment for calibration.
And Klaus, can you explain us what it's for?
Sure, making the sensor fusion super accurate. AVL in Roding is all about ensuring that everything is fine-tuned for a safe and autonomous driving. Adverse weather conditions are physically simulated there to create a real-world and reproducible and therefore comparable tests to ensure a high level of maturity in the perception results.
But besides the sensors, there is also other factors to evaluate the accuracy of the data.
Coralie, what are they and what makes them so accurate?
First, there is the GPS. It gives the vehicle exact position on Earth, while HD map offer a detail of the road, marking, and traffic sign. Inertial measurement unit, for short IMU, measure the movement when GPS fails. In addition, V2I and V2X communication allow the users to use information from traffic light or other vehicles. Sensor adapt driving behavior to environmental and weather conditions. And real-time traffic data optimize routes and driving strategy, all to keep your ride safe and smooth.
So let us explain how we in AVL create the precise world around us out of the chaos of data.
First, there is data collection. Every autonomous vehicle is full of sensors: LiDAR, camera, radar, ultrasound, GPS, IMU. They're like data sponges that look for information from everywhere. But raw data is like a wild circus. So we roll up our sleeves and we get into this pre-processing stage. We have to align, to clean, to sync everything. It's like taming a wild circus.
Then comes data conversion. You know, every sensor speaks a different language. Our perception software acts like a translator, turning it all into a common language. It's how we build the world around the car, using LiDAR points and camera images.
And here it gets exciting with object recognition and road segmentation. Our software thinks like a police patrol, using AI to detect cars, pedestrians, trucks, and traffic signs. But it doesn't stop at thinking. It combines everything. LiDAR and camera information are combined to create a 3D world in sensor fusion.
And it doesn't just look, it analyzes. It looks into the details, the shapes, the sizes, the speeds. It's like a real Sherlock Holmes on the road. Then, scene understanding. It's not just seeing, it's comprehending. Our perception software knows when a pedestrian is crossing, or where a car is parked, or when a traffic light is on.
And perception software got the GPS on each side for precise location. With mapping and localization algorithm, it always knows where objects are. It can track them like a spy in action, predict their next move, and always keep it updated.
So in the end, it transforms a crazy mess of data into a precise and thrilling world outside. It is like a high-tech show on the road, where we do the magic. As this tech talk on autonomous driving, SDVs and perception software comes to an end, it is clear that we are on the edge on a new era on mobility. The achievements discussed underline the incredible potential and challenges in this field. Let's continue to innovate, collaborate, and drive towards a safer and more autonomous future on our roads.
Thank you everyone for joining us. So let's keep pushing the boundaries of technology.